Hi everyone, in this video we're going to go through 15C, measures of spread. So measures of spread basically just tells us how varied our data is. So if we think of our two methods classes, okay, and your last SAC, your means were quite similar, but maybe for one class you had a bigger spread. So your smallest value and your highest value, which is your range, the range for one class was a lot bigger than the range for the other class. And I'm just pulling values out of the air. So let's just say for one class, the lowest value was 20 and the highest value was 100. So you have a range of 80 values. And then for the other class, they had a range from, say, 50 to 80. Okay, so you could look at, but they both had the same mean. So if we look at this diagram here, you can see the means, whoops, let me just use my highlighter. The means are in the same spot because they're symmetrical. Okay, so this would only apply for symmetrical data, and these are symmetrical, not skewed. The means in the middle, but the red curve would represent the data for the class that got between 50 and 80, and the blue, see how it's more spread out, would be the class that got between 20 and 100. So the variance just tells you how spread the data is, and the standard deviation tells you how far away you are from the mean. All right, so with your variance, we use this formula here. Let me just highlight it. Okay, so x minus the mean, so remember u equals the mean, times f of x. All right, so we're using definite integrals again. Now, just down here, we do need to calculate the mean first. All right, so, sorry, I was just going to refer you back to this formula here, but we can use either one. So we need to calculate the mean if it's not given to you, and then you calculate the variance. All right, your standard deviation, just like it was for discrete random variables, is just the square root of the variance. So you just calculate the variance first and then take the square root to get your standard deviation. If you were given the standard deviation and you had to calculate the variance, right, you just square your standard deviation. And maybe you were given the standard deviation and the mean, and you had to find, this standard deviation, maybe a little bit more information, you had to find the expected value. So just make sure you know that these formulas are interchangeable. All right, so let's move on to this example. So find the variance and standard deviation of the random variable x, which has a probability density function. Okay, so we've got, the function is 0.5x, where x is between 0 and 2. All right, so our formula for variance is written here. So we do have to find the expected value of x squared first. Okay, so you can either find, let me just scroll up. So we're using this formula here, or the example is, or you could use this one up here where you're finding the mean. It doesn't really matter. All right, so it's probably easier just to find mean of x squared. So remember, when we're finding the expected value of x squared, we're just, instead of just using x as we would if we were finding the expected value, we're putting in x squared times f of x. All right, let me just go back to 15a, because you might be thinking, what is she doing? Oh no, sorry, 15b. All right, so there's our expected value formula. All right, so remember that. All right, so expected value, we put the x here. If we're using finding the expected value of x squared with x squared, we're just substituting x squared in there. Sorry, lots of notes. All right, so we're going from x equals 0 to 2. All right, got x squared, and then our function 0.5x, which was given to us in the question. You can see they've taken 0.5 out as a common factor, and then x squared times x gives you x cubed, and then you just find your antiderivative and substitute in 2 and 0, and you get 2. So your expected value of x squared is 2. All right, so they've, and I haven't put it in here, so they've actually found the expected value. Yeah, it's 4/3 in a previous example. You should know how to do that. Okay, so I just showed you before when I scrolled back up to 15b, how to find the expected value. So there it is, 4/3. So then you just substitute it into the variance formula, which we had up here. Okay, so that's used here. So we're substituting in 2 and 4/3, okay, and then we get 2/9. The standard deviation, so that's our variance. Our standard deviation is just the square root of that. So if you had it as an exact value, it's square root of 2 on 3, or if we did it on the calculator to get the approximate value, we get 0.471. All right, just the same with discrete random variables when we're looking at 95% of the values. Remember, 95% or 0.95 of the values are between 2 standard deviations from the mean. So we've got, actually, sorry, I don't want to highlight that. Okay, so we're going, your probability, 0.95, when you're between 2 standard deviations below the mean and 2 standard deviations above the mean. So remember, mu is your mean minus 2 standard deviations, and this is the mean minus, plus 2 standard deviations. So if I go back to my curve, basically if I just look at the blue, there's your, I was about to use the wrong notation. There's your mean. So I was going to use the notation that you use in further maths, but I'll use what we use in methods. There's your mean and 2 standard deviations. Okay, so if I just go up to the blue, so what that basically means is this section here is 0.95, all right, 95%. The majority of people are 2 standard deviations either side of the mean. All right, let's move on to the interquartile range. Now, I did the interquartile range when I did a question in class. So it kind of relates to what we did in 15b when we looked at the median, but your interquartile range looks at the middle 50%. So we go from the 75th percentile minus the 25th percentile. And as I did in that lesson, Q3 and Q1. Actually, I think I did a video. Now I can't remember. So long ago. All right, so your interquartile range, I explained this in, I can't remember whether it was class or in a video, but it's just your middle 50%. So if I was to look at a curve again, it doesn't have to be necessarily symmetrical. So there's your mean. So either side of that is 50% or 0.5. And if we're looking at the interquartile range, you've got your mean in the middle, but if I was to then halve the bottom half and the lower half, this is at 0.25 and this is at 0.75. And then the middle part, this bit here, oops, did I put a 5 there? 5 is 50%. All right, that's your middle 50%, and this would be 25% here and 25% here. So that's where the 0.25 and the 0.75 come from. You would have done interquartile range in year 9, probably year 10. Okay, so it shouldn't be an unfamiliar term to you, but it's not hard either. So if you didn't have any trouble calculating the median in 15b, you're not going to have any trouble doing the interquartile range. All right, so your interquartile range, basically we look at the 25th percentile, or we just let it equal 0.25. So when we were doing the median, we let it equal 0.5. And we need to find the 75th percentile, so 0.75. And it's exactly the same thing that we did when we did the median. You have your lower limit, so in this case it's 0, so we're starting at 0, and you're going to some point. Okay, so they've called that A, and that point A is your 25th percentile. When you're doing your 75th percentile, again, your lower limit is 0, but B is that value at 0.75, which we don't know what it is. So you can see the working out for both the 25th percentile or the lower quartile and the 75th percentile or the upper quartile. And then the interquartile range, I might just write that here, your interquartile range is equal to your upper quartile, Q3, minus Q1. So you can see here your upper quartile or your 75th percentile, 0.866, minus your lower quartile, 0.5. So your interquartile range is that. All right, so let's have a look at a few questions. So a continuous random variable x has a probability density function given by, find A such that, so we're finding the lower quartile, then we're finding the upper quartile, and then we're finding the interquartile range. Okay, so we just actually, it's probably a bit too far. There's quite a bit of working here and I haven't left much space. So I'm going to do A and B over to the side and then we'll do C over here. All right, so our lower limit is 0. So we're going from 0 to our lower quartile, which we don't know, so we're going to call that A. All right, they've called it A in the question, so I'm going to call it A here. I think the example I did last week, I called it P. Doesn't matter what you use, but in this question they've called it A, so I'm going to keep it as A. Then our function is 3x squared dx, and that's got to equal 0.25. For part B, we're going to find the upper quartile. So this time we're going from 0, our lower limit, up to B. So it's exactly the same working. The only difference now is you're letting it equal 0.75. All right, so go ahead and do that. So we're going to find the antiderivative of 3x squared. So it's going to be x cubed, nice easy one. Oops, she says as she makes an error. Okay, 0a. Now I prefer fractions, so I'm just going to write a quarter. All right, so we've got a cubed plus 0 cubed is that. Okay, so a is equal to the cubed root of 1/4. I'm just going to leave it like that for now. And let's do the same for b. Now it's not a hard one to do. 0b equals, so 3/4. So we're going to have b cubed equals 3/4. So b equals the cubed root of 3/4. All right, so your interquartile range. So your interquartile range, IQR, is your upper quartile. So I'm going to use Q3 because that's the notation we do use. So we have cubed root of 3/4 minus the cubed root of 1/4, and then we can just do that on the calculator. All right, so I don't think I've ever done a cubed root on the calculator before, so I might just do to the power of a third. Save me wasting time on the video trying to find the right button. Whoops. To the power of 1/3. Yeah, I knew you were going to do that. I'll just change this to decimal. There we go. And I'm just going to write, now change that to 1/4. All right, and then I'm just going to highlight that, drag it down, minus, and highlight this. All right, so 0.27 Let's do 4 decimal places. 862786. All right, question 5. A continuous random variable x has a probability density function given by. So we have to find the value of k. All right. So we know that when it's a probability density function, it has to equal 1. So we're going to have to go from 1 to 9, k over x. Oh my gosh. I have a meeting in 10 minutes and I'm rushing. I forgot all about it. All right, dx is equal to 1. And then you're just solving for k. All right, so I'm going to leave you to do that. Now for part B, find the mean and variance of x, giving your correct answer to 3 decimal places. Actually, let's just do that question on the calculator because I need to find k anyway. 1 to 9. All right, k on x. Now, I'm just going to use k. Some students might use y just because they can't be bothered finding, going to the button. Okay, so see, just don't make this mistake. Little cursor, make sure it's a big cursor before you press equals. So equals 1 because it's a probability density function. And then we're, oh, sorry, haven't put solve on. I always forget solve. All right, solve. All right, comma k, solving for k. And I want an exact value, so I'm going to redo that. All right, so k is equal to 1 over, I'll just do half, no, 1 over, all right, we'll just leave it like that. Okay, so for part B, so our function we're going to be using, oh, that's a bit annoying. Sorry, I was just saying it was annoying because we're going to have to substitute k into a fraction. All right, just also, this is also equal to 1. That 2 can come to the power of the 3, so we can have, probably should show you that just to simplify it. All right, so your function is 1 over natural log 9 over x. So we've basically got 1 over log divided by x. So we're going to have 1 times 1 over x. So f of x is equal to, and this is important because you can't work with this original function. So you need to be able to transpose to get it, your function like that. Okay, so we're going to find the mean first and then the variance. So your mean, so we're going from 1 to 9 of f of x. No, sorry. X times f of x because we're finding the mean. So x times f of x, which is 1 over x log 9. All right, so once you've found the mean, and I might just write it down. Okay, so we've got the mean is 4 over log 3, natural log 3, so you can do that by hand. This x, sorry, I know you can't see my cursor. This x will cancel. This, hey, oh my gosh. What's going on? All right, this x will cancel out with this x. So you're really just dealing with 1 over log, natural log 9. Okay, so you should be able to do that by hand, definitely on your calculator. So we've got our mean here, and then we've got the expected value x squared. Okay, so we're on our way to find the variance now. Okay, so once you've done all that, there's your answer, 20 over natural log 3. So your variance, which we can denote as your standard deviation, or sigma squared, is equal to EX squared minus your mean squared. So we're just using the variance formula here. So 20 over log 3 minus your mean squared. We're going to square all that, and then obviously you can just put that into your calculator. So let's just do that on the calculator. I'm trying to find everything. 20 over log 3 minus, probably should put this in brackets. All right, so 4 over log 3. And we'll just get the exact value just for fun. So don't really need to write that, just for fun. Okay, and then we'll just do the approximate value. So 4.948. Then if we wanted to find the standard deviation, remember the standard deviation is just the square root of that. So we can just go back to the calculator. So the square root, and I'm just going to highlight that and put it in. So 2.224. And notice that I dragged the whole thing in. So never use rounded values, always use as many decimal places as possible. All right, I'm going to have to finish the video here because I'm about to go into a meeting. But girls, have a go at those other questions if you can. Otherwise, I'll do a second video for them very soon. Bye.